Okay, so hello everyone. In this video, we will cover UDP protocol, User Datagram Protocol. So, in this video, we will discuss introduction to UDP, then UDP header, then UDP application, and the very important thing, what is the difference between TCP versus UDP? Okay, transmission control protocol and User Datagram Protocol. So, in simple terms, if you want to understand this topic, then I can take a real life example. Like if you watch a video in like high definition in HD quality, if there is any pixel drop, okay, like there is any pixel drop or pixel losses, then the video will reload. So why this is happening? Because of TCP. TCP will request that pixel again, then video will be continue, okay. But in UDP, if you are using any YouTube live stream, or if you are doing any Skype call or anything, then what will UDP do? It cannot show us the blank screen, but we can compromise with the quality. You can notice that in our video call, or like in any live streaming, there will be any glitches, but there is not like a blank screen is showing when the pixel is dropping. But we can compromise with the quality, but we are like requesting the continuous data flow. This is the main difference between TCP and UDP. So let's start the topic. The topic is UDP, User Datagram Protocol. In the transport layer, we have seen that two protocols are very important, TCP and UDP. So we are talking about UDP in this session, okay. We have also talked about TCP in our previous video. First, I want to tell you about UDP characteristics. UDP is connectionless. What we have seen in TCP was connection oriented, but UDP is connectionless. What is meant by connectionless? Let's say a client wants to make a connection with the server. If a client wants to transfer data to a server or from any one machine to another machine, what does TCP do? First, it establishes a connection, and after establishing the connection, data transfer will start. But in UDP is connectionless, meaning we are not making any connection here, okay. It's not like a telephone network where first you dial up, then get a dial tone, then there is a connection. No, there is nothing like that. It's like a postal service. If I want to send any mail or letter, then without making any connection, I will simply write the letter, put it in the envelope, and post that letter. So UDP work exactly like that postal service. What can we assume the letter as? The letter is as data, okay, which is known as payload in technical terms. Payload means the pure data. We put that pure data into that envelope. What is envelope here? The UDP header. Each protocol has its own envelope, like its own header. I am taking this just an example for the header by which that letter reaches its proper destination, okay. Now if I want any functionality other than basic delivery, let's say if I am sending 4 or 5 letters, and I want those letters to arrive in order, like, and none of these letters should get lost. These are the different functionalities. So TCP follows all those functionalities, but UDP doesn't, okay. The first important characteristics of UDP is that without making a connection, we write the data and send it to the server, okay. We simply send that data to another machine without establishing a connection. UDP is unreliable. We have read that TCP is reliable, but UDP is unreliable. Due to this characteristics, if I am sending some packets and 1 or 2 packets get lost, UDP doesn't care about that loss, so it is unreliable. So UDP has no ordering. If I'm sending 3 or 4 packets, packets 1 2 3 4, it may happen that like first I receive packet 3, then packet 4, then packet 2. Why? Because there is no sequence number, okay. We are not using any sequence number in UDP, but we have seen that in TCP that we have used a sequence number in TCP, okay. Now we will discuss about UDP header structure, okay. In TCP header structure there were many options, but in UDP header there are only 4 fields, but one field is here is optional, okay. So there are only 3 mandatory fields. So the first field is source and destination port, okay. The first field is source port and second is destination port. So we have already discussed ports, that for end-to-end delivery we use port numbers, okay. The maximum port number range from 0 to 2 raised to power 16 minus 1, which is 0 to 65,535. From 0 to 1023 are well-known port numbers, okay. We have discussed that. After that, some are registered port numbers, and then there are normal port numbers which we use in our systems, okay. If I am sending data from my system, which application is sending data, that application will have a port number. How do we get that port number? When we open a browser and connect to the internet, the operating system assign a port number to that browsing application. If I am accessing the web server through that port number, or accessing FTP or sending mail, there are different port numbers. For example, if I am sending mail, I might use port number 25. For mailing, that's that's the destination port number. Okay, source port and destination port are mandatory fields. Third field is length. This is a 16-bit field. Okay, the length field uses 16 bits to represent the size, but the actual maximum size is 2 raised to power 16, means 65,536. The range of number is 0 to 65,535, where 65,535 is maximum number. Okay, so the maximum size of the UDP segment can be 65,535 bytes, which is the total length of the whole segment. But in the total length, there are two things: header and payload. Payload means pure data, which comes from the application layer. The UDP header is always fixed at 8 bytes. So if it has a header of 8 bytes, then pure data can be 65,535 minus 8, which will be 65,527 bytes. This is the maximum size of payload. Data can be less than this, but cannot be more, because the 8 byte of header is compulsory. Okay, now the other field is checksum. Now checksum is an optional field. Checksum is used for error control. We have seen that in TCP also. Checksum is used for error control. Okay, we use checksum for detecting errors. How do we calculate checksum? We calculate it the same way in TCP and UDP. We can take the UDP header with all its values: source port, destination port, length, plus the data, plus the pseudo header of IP. Combining all these three, we calculate the checksum. Checksum is like the hash value. Okay, we find a unique value of data. If something changes in that data, the unique value will also change. Okay, the receiver will know that the hash value they are receiving and the one they are calculating have a difference, through which they will know that there is some kind of error. Now, what does pseudo header of IP mean? In the IP datagram, we use an IP header in the network layer. We don't use the whole IP header here. We only pick those values which are fixed, meaning which remain the same throughout the transmission. Okay, like source IP address, destination IP address, protocol type. These 3-4 fields are fixed in the IP datagram. It remains the same in the IP header throughout the transmission. Okay, that's why we take only the pseudo header of IP. We calculate a unique hash value by taking these three things and send that value along with the data. When the receiver gets the data, they also take these three things and calculate the hash value. If both hash value matches, then it means there is no error in the data. If they are different, it means there is some kind of error. Checksum field is optional in IPv4. In IPv6, which has been recently launched, the checksum field is mandatory. We have seen that UDP is a connectionless protocol. Okay, it doesn't establish any connection and directly sends data, but TCP always transfer after establishing a connection. Due to not making a connection, UDP faces problems like being unreliable, packet not being synchronized, and packet can reach out of order or get lost. Okay, you can see that after these disadvantages, which applications are using UDP rather than TCP. So query response protocol. So first, our application working on query response: one request, one reply. If I am requesting, querying, and I get an answer, in this type of application we don't require connection establishment. Okay, a simple example is DNS, domain name server. If I write any domain name in a browser, we generally remember domain names, not IP addresses. Okay, when I write a domain name, where does that domain name go first? To the DNS server to find that IP address correspondent to that domain name. Okay, for this I don't need to build a connection. I'm simply requesting what is the IP address of google.com. The response is this is the IP address of google.com. Okay, wherever one request one reply applies, we use UDP because it works with the less overhead. Overhead means the extra information we add to the data, the header. TCP header has many fields, but UDP has only 4 fields, and checksum isn't even mandatory also. So on average, UDP adds 3 things to the data, making overhead much less compared to the TCP. Other examples include DHCP, Dynamic Host Configuration Protocol. If I have a MAC address but no IP address, I will ask my MAC address is this, what is my IP address? It's a simple question with the simple answer. Now, other thing is speed. This is a very important factor. The first one was query based, and now the speed. Okay, this is a very important factor. Wherever I want high speed, I use UDP. Okay, because of less overhead, UDP works faster. What application need this? Online games or voice over IP? In these kind of applications, speed matters. If I use TCP, it uses flow control and congestion control. In congestion control, if packet are going continuously and even a single packet get lost, TCP will try to retransmit that packet. That affects the speed. That's why we use UDP. We don't want congestion control method that suddenly reduce our speed. Okay, so we want to maintain constant speed. Online games need this because if the game pauses for 1 or 2 seconds, other players might eliminate you. So that's why we use UDP in speed based application. Okay, now The other thing is broadcasting and multicasting. For broadcasting and multicasting, we use UDP. Broadcasting and multicasting uses protocol like RIP, like routing information protocol, as we discussed this in our previous videos also. You can check out that. In distance vector routing, every 30 seconds, a node shares its routing table with neighbor nodes. Okay, we have discussed that one node shares its routing information with multiple neighbor nodes. Okay, if I use TCP here, this person would have to establish connection with all the receivers. How many connection would need to be established? There are many. Okay, what does establishing a connection mean? Keeping buffers, reserving bandwidth, reserving memories just for transferring one message. Okay, but in broadcasting and multicasting, we simply want to send a message to a group. We use UDP. We don't ask anyone to reserve buffers or bandwidth or anything resources. We simply send that data to many people. Okay, now the other thing is continuous streaming. Continuous streaming means packet come at continuous speed. In online stream like Skype or YouTube, you never want your video to pause or streaming to close. Now streaming continues, video keeps playing. Okay, as we discussed in the beginning of the video, UDP supports continuous streaming. For example, when playing a video on YouTube in HD mode, why is the speed low in high definition? Because in high definition, even if a single packet contains pixel drops, then TCP will stop and retransmit that particular pixel before continuing. That's why HD plays slowly. But if we play without HD, we use UDP by default. We are not concerned about clarity. We want speed maintained and fast streaming. Okay, in a application like Skype or YouTube streaming, we use UDP rather than TCP. Now, the other thing is stateless. UDP is stateless. Now, what is stateless? There are two types of protocol: stateful and stateless. Okay, stateful means making a connection and saving the connection values. Stateless means if you are connected to thousands of clients, you go to stateless. HTTP protocol is stateless. It doesn't store data from the thousands of web servers you access. But Amazon and Flipkart are stateful. They are they are tracking every page you click. Okay, now UDP is stateless, maintaining overhead as low as possible. Okay, now what are the major differences between TCP and UDP? So let's see the comparison. Okay, let's see the difference between TCP and UDP. Both are transport layer protocols, but when we send data using either TCP or UDP, what are the differences? The first major difference is that TCP is a connection oriented and UDP is a connection less protocol. Whenever TCP does data transmission, it first establishes a connection, then start data transmission. UDP doesn't care about connection. Okay, whenever it gets data from application, it start transmission immediately. The other thing is reliability. Reliability comes directly from connection. When we create a connection, it's like a telephone network. After creating the connection, data reaches reliably. Okay, reliable means I get a guarantee that all my data bytes will definitely reach the receiver. But UDP has less reliability compared to TCP. Now, other thing is ordering of packets. Okay, TCP follows ordering, but UDP has no ordering. If I send packets P1, P2, P3 at the receiver, they can reach in any order. Okay, because UDP packets follow different networks. If packet go through different networks, they won't reach in order at the receiver. But in TCP, packets will always reach in order, because the first a connection is established like a telephone network, the data flows through the established path sequentially. Now, the other thing is error control. Error control is mandatory in TCP. We use checksum to detect errors. Although UDP also has checksum in its header, the difference is that error control is optional in UDP. Okay, you can send data without checksum by simply putting zeros in the 16-bit checksum field. Okay, but if you are sending data through TCP, you must calculate checksum. Okay, and send it to the data so the receiver can verify that there is an error or not. Now, the other thing is transmission speed. TCP has a slower transmission speed compared to UDP. TCP isn't very slow, but relatively UDP it's slower. Okay, compared to UDP it's slower. UDP has faster transmission because we send data without establishing a connection. Okay, the other thing is overhead. When sending pure data, payload like pure data is payload data from application layer, we cannot send only data. We need a header containing source address, destination address, port number, IP address, MAC address, etc. This extra information is called overhead. Okay, TCP header is of 20 to 60 bytes, UDP header is of 8 bytes. So TCP has many options for flow control, error control, different flags, etc, like etc. Okay, TCP minimum header is 20 bytes, UDP is fixed at 8 bytes. Okay, obviously TCP has more overhead. Now, flow control and congestion control. These are important condition in TCP. When sending data, TCP cares about how much data the receiver can accept and what's the capacity of network. TCP uses algorithm like AIMD to control congestion. Now, UDP has no flow control or congestion control algorithm. If data is lost due to congestion, TCP will retransmit the same packet, but UDP doesn't care. Lost packets are lost forever. Now, application. Major TCP application include HTTP. Whenever we transmit web pages, HTTP uses TCP to achieve reliability. Okay, we use FTP, file transfer protocol uses TCP because even one byte gets lost from a file, you can't open that file, all bytes must be received. Okay, so FTP and HTTP uses TCP. Now major UDP application include DNS, domain name server, and DHCP, RIP, routing information protocol. These needs fast transmission rather than reliability. Okay, so YouTube sends data through TCP because it doesn't want data loss, but YouTube streaming is based on, like, we can say UDP. Okay, high definition video uses TCP, but standard definition can use UDP. Okay, in Skype and live conferencing we use UDP. So wherever reliability is needed we use TCP, and wherever fast transmission is needed we use UDP. So that's all about UDP User Datagram Protocol. So that's it for this video. We will meet in next video. Until then, bye bye.